Bismillahirrahmanirrahim. Let's continue with our study of chapter 6 with acids and bases. Chapter 6 is about the chemistry of life, or chemicals, molecules that make up living things. Here we should briefly survey the concepts of acids and bases and review some things that you may know. If you have a beaker of an acid sitting over here, for example, the strength of an acid is dependent upon how much of hydrogen ion that it has. So an acid is a compound that has lots of hydrogen ion and relatively few hydroxide ion, and a base, so this is an acid, and a base is a compound that has lots of hydroxide ions and very few hydrogen ions. So this here is a hydrogen ion, which is just a hydrogen atom with this electron stripped off, right? So hydrogen atom is like this with one electron, right? One proton, electron. When the electron leaves, that's a hydroxide ion because a proton minus the electron. So hydrogen ion is just a hydrogen atom without electrons. So acid is a compound that has lots of hydrogen ion. Okay, and hydroxide ion is like this. Okay, this is called hydroxide. Hydroxide ion is oxygen attached to hydrogen with a negative charge. Okay, so acids are chemicals that have lots of hydrogen ions, and bases are chemicals that have a lot of hydroxide. And where they come from, etc., it's more trickier because then this will become more of a chemistry session than we have time to do. But nevertheless, we have to appreciate is that the pH is a measure of indirect measure of hydrogen ion concentration. If you remember from chemistry, pH of a particular substance is negative log of concentration of hydrogen ion. Well, what does that mean, right? So now what that means is actually, okay, see, hydrogen ion concentration, and this bracket suggests concentration. This means concentration of hydrogen are very small numbers, even in strong acids and bases. So these are like scientific notation numbers. The pH of water, for example, okay, is 7. Okay, this corresponds to a hydrogen ion concentration that's 1 times 10 to the negative 7. Okay, so now pH just converts this scientific notation term into a term that does not have a scientific notation. So its pH is just kind of like anti-scientific notation. These two numbers are the same thing. So it's anti-scientific notation and converts very small numbers into numbers that we can understand and use more readily. Okay, so water has a pH of 7, and that's a neutral pH. Okay, it's neutral. Okay, so the water that you drink has a pH of 7. Okay, now if somebody has a glass of water, right, and they add acid to it, what they're adding is lots of hydrogen ions. Okay, and then it will become more acidic. That solution will become acidic, and the pH will decrease. So the lower the pH, okay, the more acidic it is. On the other hand, if somebody adds more hydroxide ions to the solution, then it will become more basic and it will become more base. Okay, stomach pH, for example, can be like 2 or 3 pH units. So it's quite as acidic, has lots of hydrogen ions because the stomach secretes hydrochloric acid. So a very basic understanding of acid-base is acid is a substance that has lots of hydrogen ions. A base is a substance that has a lot of hydroxide ions. Okay, the more hydrogen ions there are, the lower the pH, and the more hydroxide ions there are, the higher the pH. A pH of 7 is neutral. Okay. So pure water, as pH is 7. Normal pH is about a normal human blood pH is about 7, and grapefruit juice is acidic, lemon juice, gastric juice very acidic, tomato juice is acidic, and some bleach is basic. Okay, oven cleaner. Now, people commonly think that acids are like bad and bases are not so bad. Now, actually not true. They can be equally bad. A strong acid can do as much damage as a strong base, or a strong base can do as much damage as a strong acid, depending on how strong it is. If they're equally strong, they can both do equal damage, so to speak. Okay, so stronger acids have lower pH, stronger bases have higher pHs, like this. Okay, and again here, acids have more hydrogen ion concentration. Okay, bases have more hydroxide ion concentrations, like that. Again, a neutral pH is 7. Here gives examples of some household products with different pH. Battery acid is like 1. Okay, ammonia is like 11 something, 12, and lye is even stronger. Coca-Cola, pretty acidic. Banana, ammonia. Okay, so that's acid base science. The next topic in the agenda is diffusion. Inshallah, we'll talk about that after a brief pause. Until then, as-salatu wa-salamu ala rasulillah.